Okay, we're on the Sage code again. I'm going to go back to the terminal. I'm going to clear the screen. It's from prior work, by the way. And I'm also going to reset Sage. And reset basically just gives you a clean slate, by the way. And I'm going to type in, 11. And I clearly see what they're doing. It's 34. This pertains to the notes, by the way. Divide by 9. And yeah, it really doesn't do much. All right. Now, someone says, what did it do? It did what it considered a simplification, by the way. All right. Now, granted, I don't think it's a great simplification, but nonetheless, it is a simplification. And you may wonder what it did. 9 goes into 34. Let's see, three times, right? So 3 times 9 is 27, and then a remainder of 7, so 7 ninths. So what I'm going to do is I'm going to do that numerical approximation. So underscore, that's the output from the prior input, and then the n is an abbreviation for numerical approximation, and it's a function call. That's why those parentheses are there. And what do you get? 8, 5, 9, 3. All right? So what I want to do, go back over here, and I'm wondering what question that pertains to. Now let me just scroll this. No, it looks like this question over here. All right? And what was the question? How many digits are there in the integral part? Well, I can certainly do it on a calculator, and I would get there would be 4. All right, 4 digits. How do I know that? Well, I just did it over here. But that's not the point. The point is I'm just looking at, really what's computation produce? It produces those 4 digits in the integer part of the number. 4 digits. All right? Let's go back to Sage again, because there's more Sage there, and it pertains to the problem set. And looking at this over here, again, what I'm going to claim over here has something to do with the problem set. Let me clear again. I'm going to reset again. I'm doing another problem. And x and y are variables. And then I get this assume. I'm just going to copy paste. Assume y is greater than 0. And I'm going to assume x is greater than 0 too. I'm just going to type over it. And then I'm going to assign f that this is x log x. And that should be sort of in your memory if you studied the notes, by the way. And then, write down f of y minus f of x. And it gives me this over here. And then I write this over here. And again, I'll go back over the notes in a second to look at where this is coming from and why we're doing this over here. Now, what I notice about this over here, looking at it, and I know it looks strange to you, this over here and this over here, although look radically different to me, produce the same output. Now, how do I know that? Looking at this thing over, it's really going to be x to the minus x, log of x minus x, and that will be log y to the y, which is really just this thing over here. It's a simplification of a log, by the way, provided that x and y are positive numbers, by the way. All right, so I'm going to look at this thing over here, and also I'm just going to copy paste this. Wow, didn't give me a number. So what I'm going to do over here is I'm going to ask it to approximate the number. And I get 4040 dot a bunch of zeros, by the way. I probably could figure that out looking at that. But anyway, let's go back over the notes, and I'll point out what I'm really kind of doing here. And you might find this to be quite strange that I'm actually looking back over what we just did. And I think it was this problem right over here, right? If you remember, I did find f of x out. Back to Sage. And f of x we found to be x log x. Let me show you that's written. Go back to Sage. Took us a long time to get there, though, I'll tell you that. And we figured it out. And we figured out f of x was x ln x. Really what I was doing with this business over here was I was just verifying that if that's what I found, that if I did f of y minus f of x, it'd be down to this over here. And that's what I'm seeing over here. I'm seeing that I'm just typing those things in. And they are identical, by the way, all right? Provided that x and y are positive numbers. The other one to verify is the computation, which is really the question they had. And it's 4040, and that was their question. And we did get that answer, by the way. Now, Sage didn't display that answer. I had to force it to do a numerical approximation. But I hope you're convinced by the work that we did that we got 4040. Thank you.